is a pre-algebra video on solving equations where we're going to simplify expressions by combining like terms, and where we will be using the distributive property also. We'll also do a few simple word problems that involve combining like terms. So last time we did problems like we may have had two-step problems like 3x plus 5 is equal to 17, and we subtracted 5 from both sides, and we got 3x is equal to 12, and then we divided each side by 3, and we got x is equal to 4, and we learned we could check those and so forth. This time we're going to do a little bit more here, in that we're going to have some more complexities here. As a general rule, we simplify things first when we can. So I'm going to delete that there so give us some more room. So let's say I have this expression here, or this equation. So up here, and let's get a color here. Let's say I have 4k plus 8k plus 5 is equal to 29. Well, what I want to do first is simplify, because things are going to be too complicated if I don't. So what I'm going to do here is I can combine these like terms here. So I have 4k plus 8k. Think if I have 4 kittens plus 8 kittens, I have 12 kittens. So I have 12k plus 5 is equal to 29. So I'm just combining like terms. So first I start off by combining my like terms, and then once I've done that and I have the equation as simplified as I can on each side, then I go ahead and start doing things to one side and then doing it to the other, with my goal of getting k by itself. So I'm going to subtract 5 from both sides, because usually I do the addition or subtraction first. And I get 12k is equal to 24. And then I divide both sides by 12. And I get k is equal to 2. Okay? Now, there's a common introductory word problem that is used where we do combine like terms. So the word problems go something like this. They're usually something like the sum of 3 integers is equal to, or just is, 84. So we're looking for 3 integers whose sum is 84. And a lot of people who think about this, they sort of take 84 divided by 3, and that sort of gives them the middle number and so forth. So, if you're bright, you can do that and so forth. But what we're here to do is learn the tools of algebra. So if you want to do it that way for fun, that's fine, but you also have to do it the algebraic way. And this is the algebraic way, and this is a good way to start to learn how to do algebra word problems. The first step we do is we define a variable. And defining a variable means, say, we're going to let, and then we give it a variable name, and I'm going to call mine n. So let n equal the first integer. Okay? And then once we've defined that integer, we're going to use that to write an equation now with just that one integer. So if n is the first integer, and these are, the sum of 3, I forgot to write this here, consecutive integers. So consecutive integer would be like 3, 4, 5. or 7, 8, 9. So consecutive integers. Okay? And so if n is the first integer, then the second integer is n plus 1. So that's equal to the second one. And I'm going to abbreviate integer here because it's hard writing on the screen anyway. And then I'm going to go n plus 2 is going to be the third integer. So let's think of that. Let's say I had three integers and they were 2, 3, 4. Well, I start with 2, and then the second integer is 2 plus 1, and then the third integer is 2 plus 2. And that gives me 2 plus 1 is 3, and then 2 plus 2 is 4. So three consecutive integers will always be that way. There'll be n, and n plus 1, and n plus 2. Well, we know if we add these three integers together, we're going to go n plus, that's the first integer, n plus 1 plus n plus 2. So let's make sure we're clear on what's happening here. This is the first, wanted to get a new color there. This is the first integer. This here is the second integer, and this one here is the third. So the first integer plus the second integer plus the third integer, go back to our problem, original problem, is equal to 84. And so now we are going to simplify this expression. Well, we have n plus n plus n, that's 3 n's. Okay? And I have 1 plus 2, that's equal to 3. And then all that is equal to 84. And now I'm going to solve that equation. I go subtract 3 from both sides. And 3, just 3. And I get 3n is equal to 81. I'm going to divide each side by 3, and I get n is equal to 27. N is the first integer, so that's 27. The second one is n plus 1, or 28. And the third integer is n plus 2, or 29. If I go ahead and add 27, 28, and 29, I better get 84. And if I look at that, I get 15 plus 9 is 24, so I get a 4. And I do get 84 if I add those two together. Let's do another one. So I'm going to get a new screen, and we're going to do, it will be the sum of, so I'm telling you the sum of 3 consecutive odd integers let me erase a little bit. So the sum of 3 consecutive odd integers is, and usually I go off to the side and I think of these things, and so I'm going to do that right now. And I get, I'm not telling you though, 51. Okay? So think of this. Let's say, think of 3 consecutive odd integers. Let's say I have 3, 5, and 7. Well, as I go from 3 to 5, I add 2. And as I go from 3 to 7, I add 4. So the way it goes is I'm going to define the first integer as let n equal the first integer. Once I know that, then n plus 2 is equal to the second integer. I'm just abbreviating integer there. And n plus 4 is equal to the third integer. Now, I'm not going to do it because it's going to be the same, but this is the same if it was consecutive odd integers, by the way. Because consecutive odd integers, think of like 2, 4, 6. To go from 2 to 4, it's n plus 2, and to go from 2 to 6, it's n plus 4. So 2 to 4, it's n plus 2. 2 to 6, it's n plus 4. So same type of thing here, but whether it's even or odd. So I'm going to go n plus, so the first number, n, plus the second number, or integer, n plus 2, plus the third integer, n plus 4, is equal to 51. Well, I go 1, 2, 3. I have 3 n's plus 6. That's the 2 plus the 4 is equal to 51. Subtract 6 from both sides. I get 3n is equal to 45. Divide each side by 3, and I get n is equal to 15. That's the first integer. And then the second one is n plus 2, or 17. And the third one is n plus 4, or 15 plus 4 is 19. And those are our three consecutive odd integers that add up to 51. In how I did the problem, you saw me pause for a moment. I said, well, let's take 15, and then, oh, the next one would be 17, the next one would be 19, add those up, I got 51, and then I create my problem. So you can create your own problems doing these also. I'm now going to do a problem that involves the distributive property. So this is a little bit different thing. It's other sort of multi-step equation here. So I'm going to hit new and don't save. And so I'm going to do this equation right here. I'm going to do it two different ways. Let's say I have 2 times 3x plus 2 is equal to 40. Well, this is a pretty complicated equation because I can simplify this left side here by doing the distributive property. So usually I want to do that first. So I'm going to go ahead and do that first. I wanted to get a different color. There we go. So I have 2 times 3x. 2 times 3x is 6x. 2 times 2 is 4. So 6x plus 4 is equal to 40. Now, we've had ones like this before. I subtract 4, and then this is 6x is equal to 36. These divide each side by 6, and I get x is equal to 6. I could plug that back in if I took this 6 here, plugged it back in, and actually I would get 3 times 6 is 18, plus 2 is 20, times 2 is 40, and that checks. So the idea here is that usually we want to simplify by doing the distributive property here. Notice this one's sort of interesting, though. I'm going to rewrite it over here. It's 2 times 3x plus 2, sorry, that's an x, is equal to 40. Notice I could, usually we do like addition or subtraction first, but I see that 2 here in the 40 here, this is 2 times something is equal to 40. Well, I could divide this whole side of the equation, it has to be the whole side of the equation, by 2, and then I have to divide the other side by 2 also. And then these 2's would cancel, and this would be 20 over here. So that would simplify as to 3x plus 2 is equal to 20. and then I'm going to subtract 2 from both sides, and I get 3x is equal to 18, or I get 3 divided by 3, I get x is equal to 6. So this points out that equations, you and I might do an equation slightly differently than each other, but as long as we're doing the same thing to both sides of the equation, and it is always to the whole side of the equation, then we're going to come out with the same thing. Let's see. I'm going to do one more here, just to get one more level of complexity. So I'll not save that. So here I have this one. I have 38 is equal to negative 2 times 3w minus 7 plus 2w. That looks really complicated, but we're just going to take it step at a time, simplifying first and then doing something to each side of the equation to get the w by itself. So I'm going to simplify first, and when I simplify, I write down the entire equation. Again, I just go down, and so I'm going to do some distributive property here. So I get negative 6w, and then this is a negative 2 times, like this is plus a negative 7. You know, a minus 7 is the same as adding the opposite. So this is like plus a negative 7. So a negative 2 times a negative 7 is a positive 14. So this is plus 14. And then I have my 2w out here, which is outside, you know, isn't part of this distributive property here. So I just have 2w. Now, I have some like terms I can do here because I have a 2w or negative 6w there and a 2w there. So I can go ahead and combine those like terms. And so I'm going to go ahead and do that. And so I have, again, I write down the entire equation as I'm simplifying each time. So negative 6w plus 2w is a negative 4w plus 14. Now we've seen equations like this before. I usually do the addition or subtraction at this point first. So I subtract 14. And 38 minus 14, that would be 4 and 24. So I get 24 is equal to negative 4w. Divide each side by negative 4. And I end up with w is equal to negative 6. So I get w is equal to negative 6. And so that's a more complicated one. And but as you just take it step by step, it's really easy. Well, it's not necessarily that easy, but it'll get fairly easy. The more you do it, the easier it becomes. So that's the end of this video.